Welcome to the 7-2 notes. We will be solving more systems of equations, but we will only be using elimination. And you might notice that your x's and y's both have numbers in front of them. So here we go. To use elimination, what you might need to do is multiply one of your equations by a number in order to match up terms so that they have the same number but opposite signs in front of them. For example, if you look at this first one, you have a negative 2y and another negative 2y. So what I'm going to do is just take the first and top equation, it doesn't matter which one, and multiply each term by negative 1, leaving me with negative 3x plus 2y equals negative 4. From here, now I can add my two equations together. This is going to end up being, let's see, 5 minus 3 is 2x. The two y's will cancel out because we have one positive and one negative. And 8 minus 4 is 4. From here, you can divide each side by 2 in order to solve for x. So x is going to equal 2. Once you know your x value, you can take any equation and plug it in order to solve for your y value. I, again, am going to choose the first one because the numbers are smaller. So 3 times 2 instead of 3x minus 2y is equal to 4. 3 times 2 is 6. Subtract 6 from both sides. And divide. So the final coordinate is going to be 2, 1. You can also graph and find the point of intersection of both equations like we did last chapter, or last section. Sometimes you might have to multiply both of the equations by a number in order to make them equal. In fact, I noticed here I have the y's are close to each other, one's positive, one's negative. What I'm going to do is I'm going to multiply the whole entire first equation by 4 and multiply the whole second equation by 3. So you're going to end up with 20x. 4 times 3 is 12, y. And 9 times 4 is 36. So there's the first equation. The second one is going to be 3 times 2, which is 6, x. 3 times 4 is negative 12, y. And 14 times 3 is 42. Add your two equations together. The 12y's will cancel, leaving you with 26x is equal to 78. Divide both sides by 26 and you will get x is equal to 3. Once you have that value, just pick one of your two equations and plug x in. I think I did the first one. Five times 3 is 15. Subtract the 15 over to the other side, and you will get 3y is equal to negative 6. So y is going to equal negative 2. So the coordinate for this would be 3, negative 2. Moving on to the last equations, why I put these is one of them will have no solution and another one will have an infinite solution, just to see what that looks like when you do elimination. Here, when you multiply this first one by 2, you're going to get 2x. 2 times 2 is negative 4y. 2 times 3 is 6. When you add them together, the x's cancel, the y's will cancel, leaving you with nothing on this side. But on the other side, you have 6 plus 1, and that's 7. 0 cannot equal 7, so this would be no solution. If you were to graph these two equations, they would not intersect. For the second one, if you multiply the top equation by negative 2, what's going to happen is you will receive negative 4x. Negative 2 times negative 1 is positive 2y is equal to negative 2. When you combine these, the x's cancel. The y's also cancel, leaving you with nothing on this side. And the 2's on this side add up to get 0 as well. 0 is always equal to 0. This means that they are infinite solutions. What that really means, if you were to graph these two things, that they would be the same line. And that is it for section 7-2. The homework is at the bottom, and you will be able to work on it in class on Monday.